Hi everyone. Hi everyone, thank you very much for watching this video. In this video I will be sharing with you about independent sample t-test, and if you have question, feel free to write your comments in the comment section of this video. And independent sample t-test is a test that we use to compare the means of groups, and it is a parametric test. Basically there are two types of tests, and one is parametric test, while the other is a non-parametric test. And independent sample t-test is a parametric test, and there are other names that we use to call t-test. It is also known as independent t-test, independent measures t-test, independent two-sample t-test, student t-test, two-sample t-test, uncorrelated scores t-test, unpaired t-test, or unrelated t-test. Okay, thus all names are the names assigned to independent samplist t-test. The independent samplist t-test compares the means of two groups. Okay, the statistical difference between the means of two groups. Therefore, we have two groups. Okay, we have two groups that we compare. While we are running an independent t-test, we must have two groups, and we compare the mean values of just two groups to conclude whether there is a statistically significant difference between the two or not. Okay, look here in the diagram. There are two groups. Okay, female students group and the male students group, and the dependent, the grouping variable is independent. Okay, the grouping variable is independent, and the test variable is dependent variable. Here, test result. Okay, exam test result is a dependent variable, and the gender of the student is an independent variable. Therefore, the gender is a grouping variable. Okay, in running t-test, okay, in running independent sample t-test, the grouping variable is independent variable, and our interest is to find out whether there is a statistically significant difference of mean values of the two groups. Okay, for example, here in this case, the test results of the students will be recorded. Okay, and the female group's test result will be on one side, and the test results of male students will be on one side, and then we will be comparing. Okay, we will be contrasting whether there is a statistically significant difference between the male students and female students. Another example, let us see second example, and the households grouping status. Okay, we classify households into two groups: households growing cash crops. Okay, households cultivating cash crops, and households not growing cash crops. Okay, there are two groups. Therefore, we compare those two groups based on annual income. Okay, annual income, and our interest is to find out whether there is a statistically significant difference between the households growing cash crops and those households not growing cash crop. Therefore, the independent sample t-test is used to find out the difference, the mean difference, the average difference. Okay, the difference in average value. Okay, between two groups. You can and let me add another example. You can classify students in one section into two. Okay, students, male students and female students. Then you can measure the weight of female students and the weight of the male students, and then you can test whether there is a statistically significant difference between the weight of the male student and the weight of the female student. The same thing you can do with the height. Okay, you can measure the height of the male students and the height of the female students, and then you can compare and contrast whether there is a statistically significant difference between the two groups. Another example, you can you can classify banks, okay, into two groups. Okay, banks located in the middle of the town, in the middle of the city, and banks that are in the periphery, in the outskirts of the city or the town. Then you can compare the profit, okay, the annual profit, the average annual profit of the two group of banks in the middle and the banks in the peripheries. Then your interest will be to find out whether there is a statistically significant difference between the profit of the average profit of the two groups of banks. Therefore, that is the basic use of independent sample t-test. Therefore, the dependent variable is 1 and the independent variable is 1 too. Okay, is 1, and the independent variable should be categorical. Okay, the independent we will be discussing, okay, in the later part of this discussion. And the dependent variable is as you see, the test result, income, okay, and the independent variable grouping variable is household grouping status and gender of the student. Okay, the point is that it helps to determine whether there is statistical evidence that the associated population means are significantly different. Okay, whether the population mean is significantly different. Okay, requirement is what are the, in order to use, we cannot simply get up and say we're gonna use t-test. Okay, in order to use a t-test, there are preconditions that are there are requirements that should be fulfilled. Okay, so that we can use independent sample t-test. For example, let me back to our previous slide. And for example, as you see, the independent variable, there are two groups. You cannot use t-test if the independent variables groups or the independent variables categories are more than 2. Okay. Put in your mind that when we are about to use independent sample t-test, we should make sure that the independent variables categories or the independent variables groups are only 2. Okay, if the group in the independent variable, the groups in the independent variable are more than 2, then there are other tests that we can use. For example, you can use a one-way ANOVA and other tests. And another, let us look one by one. The requirement is, okay, the prerequisites, the criteria. Okay, the criteria to use independent sample t-test. The dependent variable is continuous. The dependent variable should be continuous. Okay, in order to use independent sample t-test, the dependent variable should be continuous, either on interval level or ratio level. Okay, you know what is interval data. Data can be interval data, ratio data, nominal data, or ordinal data. Okay, you can refer to your research learning material. Okay, or you can Google into internet and then find out what are the measures of data. Data can be measured on interval base. It can be measured on a ratio base. It can be measured on a nominal or ordinal base. Therefore, in the case of independent sample t-test, the dependent variable should be continuous. What we mean by continuous is that let us get back to the slide again. Test result, income, both are continuous in a sense, measured in natural number. Okay, in natural number. For example, here let us see the opposite of continuous. For example, in the independent variable, okay, in the independent variable there are two groups, female students and male students. We can assign one, okay, we can code, okay, one for female students and two for male students. Then 1 and 2 are numbers, but those numbers are not continuous numbers. They are just a nominal numbers that represent male and female students. They don't show the greater or less than meaning. Okay, they don't give the true meaning of numbers. Okay, mathematical meaning of numbers. But when you come to the natural numbers, for example, test result, a student can score 50, a student can score 60, 80, 95, 94, like that. And the numbers are natural numbers. Okay. Therefore, the in independent sample t-test, the dependent variable should be measured in terms of continuous, in terms of continuous numbers, continuous number. Okay, continuous number. And the dependent variable, okay, on the other hand, the dependent variable should be categorical, should be a categorical variable. Categorical variable in the sense, a variable that can be a variable that has group within itself. For example, gender of the student, the gender of the student. Then when you say gender, basically there are two gender roles, female and male. When you come to household cropping status from the point of view of growing cash crops, then you can categorize households into growers of cash crop and non-growers of cash crop. Therefore, the independent variable should be categorical. Okay, if let us assume that the dependent variable is continuous and the independent variable is also continuous. If that happens, then you cannot run an independent sample t-test. In this case, you can run simple linear regression. Okay, but here if the dependent variable is continuous and the independent variable is categorical, and the categories or the groups or levels within the independent variable are 2, then you can run independent sample t-test. I told you before, and I want to stress once again, if the groups in the independent variable are more than 2, then you cannot run independent sample t-test. Rather, you try another test, maybe one way or another. Another requirement is that I have already told, independent variable that is categorical, okay, and has exactly 2 categories, 2 groups or 2 levels. Cases that have values on both the dependent and independent variables. Okay, a given case when we are running independent sample t-test, there should be information. For example, for student, for a student, let us say a student name it Ababe. Okay, let us say Ababe, Ethiopian name. A student named Ababe is included in the study. Okay, and in order to run an independent sample t-test, this student Ababe should have information both on dependent and independent variables. If his gender is mentioned, if his gender is recorded, but his his test result is missing, okay, then the data is not a complete data. Therefore, our result will be the independent sample t-test output will be distorted. Therefore, we must have cases. By case we mean that by cases we mean that the participant is one participant represents one case, another. If we have 100 participants in our study, then there will be 100 cases. Okay, a case means a participant. Okay, therefore a study participant okay, should have information on both dependent and independent variables. Otherwise, our data is incomplete and our output will be distorted. Independent samples or groups, independence of observation. Another requirement to run an independent sample t-test is independence of observation, or independence of samples or groups. By this we mean that, for example, if we are using gender of the student as an independent variable, it means that there are two groups, okay, two groups in the independent variable, male and female. Then by independence of observation we mean that one student cannot be both male and female, okay. He either be male or female, okay. He cannot have a dual gender, okay. Therefore, when we are running independent sample t-test, we should make sure that a participant in a study is just making it into a single group, okay. It's just a part of a single group, not sharing the characters. A case, an individual participant in the study cannot influence both groups, okay, cannot influence the result, the response of the two groups. Just he or she will be combined, okay, or a given household, if it is household, a given household will represent only one group, cannot represent two groups, okay. Any response he or she give should not be a dual response. Then random sample of data from the population. In order to run an independent sample t-test, the sample is, the participants should be randomly selected from the population, randomly selected by using different sampling techniques. The sample should be taken randomly, okay, so that we can say that the participant is truly represents the population. Then normal distribution of the dependent variable for each group. The distribution of the dependent variable is value. For example, in our example, the example that we raised earlier is the test of the test result, okay, exam test result, and we are interested to test whether there is a statistically significant difference between male students and female students. In order to run independent sample t-test on this information and on this data, we have to make sure, as a prerequisite, okay, as a criteria, we have to make sure that the test result is normally distributed for male students and female students, okay, for both groups. And in the case of households example, the income data should be normally distributed for households growing cash crops and those households not growing cash crops. And when the data is normally distributed, it normally makes a bell shape, okay, a bell shape. The distribution gonna show us a bell shape, okay, a bell shape. And homogeneity of variance is another criteria that should be fulfilled, okay. For example, violation of this criteria, violation of this requirement will distort our result, okay. For example, if the data is not if the data of the dependent variable, the value of the independent variable is not normally distributed, then we cannot run independent sample t-test, because the assumption is violated, okay. If assumptions, those are the assumptions, okay. Requirements mean the assumptions, and if assumptions are violated, then the result will be meaningless. The result will be misleading, okay. We can say that we could say that there is a statistically significant difference between the female and male students, but in actual case there might not be significant difference, okay. Therefore, we have to make sure that all this assumptions or requirements are met in the course of running the independent sample t-test. Before we actually run the test, we have to make sure that these assumptions are met. Homogeneity of variance, okay. The assumption of homogeneity of variance, requires that the two groups, the variance in two groups should be equal. Okay, the variance in two groups, the variance for two groups, for example, the variance in the female students group and the variance of the values in the male group should be equal. Okay. And another requirement is no outlier, no significant outlier. There should not be, a deviant value in the data. For example, let us assume you collected data about the income of the households, and the majority of the samples gave their income data in terms of 10,000, and then 30,000, 20,000, 40,000, 50,000, like that. And you mistakenly added, 3 zeros. Okay, the actual data is 50,000, 40, but you mistakenly added 3 zeros. Then it's gonna be in terms of billions, 50 billion or 500 million, like that. Then, including that data, that mistaken data, in the course of test, will totally distort the whole result, okay, the whole output of the test. Therefore, you have to make sure that there is no significant outlier, there is no a significant deviance of data while you are running independent sample t-test. And all these assumptions can be tested. Okay, you can test some other thing, some of the assumptions can be just observe it. Okay, you can simply check them by observing the character of the variables and the nature of the data. And others like normal distribution, homogeneity of variance, and the outliers. You're gonna check them by using softwares. Okay, and in the future videos that I will prepare, I will show you how to, for example, test the normality of distribution in SPSS or in Stata. I'm going to show you how to test homogeneity of variance in SPSS or Stata, and I'm going to show you how to find out outliers in the software. But those are the basic assumptions of the independent sample t-test. If those assumptions are not met, then you find another test. Like when one or more of those assumptions for the independent sample t-test are not met, if they are violated, you may want to run the non-parametric test, Mann-Whitney U-test instead. Okay, Mann-Whitney U-test is a non-parametric test. Okay, it is an alternative for independent sample t-test. It means that if you found your data not normally distributed, if you found your data don't show homogeneity of variance, okay, if there is heterogeneity of variance, okay, heterogeneity of variance across groups, if there is outlier, it doesn't assume homogeneity of variance, and it doesn't assume normal distribution of data. Therefore, as an alternative, if you try to test the assumptions of independent sample t-test and you found them violated, then you should turn to Mann-Whitney U test instead. Okay, and there are rule of thumbs. There are another rules for the researchers. Okay, through experience, researchers develop the rule of thumbs for independent sample t-test, and they there are basically two things, and each group should have at least 3 subjects, ideally more. inferences for the population will be more tenuous with too few subjects. Okay, in order the cases, okay, participants, at least you should have 6 participants to run a independent sample t-test. Okay, therefore, if you are interested to run to check whether there is a statistically significant difference between male and female students, at least you can include 6 participants, 6 students in your study. And another rule is a balanced design. The same number of subjects in each group. Therefore, when you are, for example, including male and female students in your study, you have to make sure that you have equal number, okay, more or less, okay, or nearly equal number of female students and male students. Okay, if one group is larger in number than the other, then this will distort the value. Okay, extremely unbalanced designs increase the possibility that violating any of the assumptions or requirements will threaten the validity of independent sample t-test. Okay, it will make the output of the test invalid. Okay, therefore you have to make sure you have the design when you are designing the subjects, when you are including the participants in your study, then you have to make sure that the number of the participants or the subjects in each group are nearly equal. Okay, there should not be this much a large difference in members of the subjects between 2 groups. Another thing is that whenever you are running tests, implicitly there is a hypothesis. Okay, there is hypothesis, and for the independent sample t-test, basically there are 2 hypotheses, and one is null hypothesis and another is alternate hypothesis. The alternate hypothesis, the null hypothesis, say that there is no mean difference. Okay, as I have said, the very interest in independent sample t-test is to test whether or not there is a statistically significant difference between the mean values of the 2 groups. And the null hypothesis, that's null means none. Okay, none. Okay, or 0. Therefore, its name, the name of the hypothesis denotes what it means. And in null hypothesis, the null hypothesis of independent sample t-test is stated that there is no difference of mean value, okay, of the mean value or the average value of the 2 groups. Okay, there is no difference of test result between male students and female students. There is no average annual income difference between household is growing cash crop and household is not growing cash crop. There is no average weight difference. Okay, our average weight difference between male students and female students. There is no average height difference between male students and female students. Okay, there is no difference, means the difference is 0. Okay, therefore null hypothesis states that in the case of independent sample t-test, the null hypothesis, since we have 2 groups, the null hypothesis says that there is no difference of mean value between the 2 groups, while the alternate hypothesis stated the opposite, and it says that there is a difference. Okay, and in symbol, it is put like this, and mu1 is equal to mu2, and mu, the letter mu represents mean 1. Mean 1 means, let us say, the mean of female students, and the mu2 means mean of male students. Therefore, then H or H0, okay, it seems, and then it means that the 2 population means are equal. Therefore, the difference is 0. Okay, mean, if let us assume the mean of female students is 50 and the mean of male students is 50. Both are equal. Okay, 50 is equal to 50. Therefore, when you deduct 50 from 50, then it will give 0. Therefore, null hypothesis is stated that there is no difference. Okay, there is no difference between the null, between the two groups, female students and male students, based on their test result. Or even if there will be any, a given number, a difference of given number, let us say 50, but the result of the female group is the average result of the female group is 54, and the average group, the average result of male students is 50. Okay, then 54 minus 52, the difference, 50, the difference is 4. Okay, 54 minus 50, the difference is 4. The null hypothesis stated that even though one could find a difference of a given number between the mean value of the two groups, that difference come by chance, not in a statistically significant level. Okay, therefore it declared that there is no difference between the two mean values of the two groups. Okay, of the two groups, and the alternate hypothesis H1 is, okay, H0 is a null hypothesis, and H1 is a alternate hypothesis. And the alternate hypothesis says that the two population means are not equal. Okay, there is a difference between male students and female students. There is a difference between households growing cash group, and there is a difference of the average income of households growing cash groups and those not growing cash groups. Or the expression in different ways. The difference between the two population is equal to 0, and the alternate hypothesis is that the difference between the two population means is not 0. Where mu1 and mu1 and mu2 are the population means for group 1 and group 2. Okay, and that is what I've said. In it's a symbolic expression. This is all about the independent sample t-test. If you have question, feel free to write your question in the comment section, and I will answer. I will reply as soon as possible. Thank you very much, and see you in another video.